AQA AS Level Maths Paper 1 2019, so this is pure and mechanics. Question 1, state the number of solutions to the equation tan 4 theta equals 1. So if you imagine just tan theta equals 1, it has one solution here. Okay, but you have 4 times as many. And if you imagine the graph transformation, you've squished it in by a factor 4. Or another way that you can think about it is, or you could just change this range here to be 4 times theta. So 180 times by 4, and then you'd obviously be able to see that instead of having one solution, you'd have 4. Dan believes that for every positive integer, and as just for this, just read through that if you want. Just try them all. Eventually, you'll see that n equals 6 is the correct answer. If you're a bit paranoid, you can just start from right to left if you think they're going to make you waste your time. It's given that these two are factors of f of x. So we're saying that f of minus 1 equals 0 and then f of 3 equals 0. So if we say this here, just plug in minus 1, you'll get this, and then plug in f of 3 equals 0 into there to get this. And then what I did was, let me see, I took these ones away. So I did this one, take away that one to get rid of the q's to get this. Get p equals 2, put it back into this one to get q is minus 3. Fully factorized. So we know that these two are factors, and then we also must have another linear factor. You could use synthetic division if you wanted twice, but that's just pointless because the other factor has to be a linear because you want x cubed. Because if you had a quadratic factor, you'd have a quartic instead of a cubic. So it'll look something like this. I expanded these two together like this, and then I equated coefficients looking at the a's and b's. Well, the x squareds and x's. So we have an x cubed here. We have ax cubed, and then we have 2x cubed, so a equals 2. And then b obviously just equals 1 because minus 3b has to equal minus 3, so b is just 1. And then factorize this back. Show that this can be expressed in this form. This is just rationalizing the denominator. This is GCSE stuff. This will be root 18 plus root 12, and then this will be 3 minus 2, which is just 1. So the bottom, you don't have anything on the bottom basically. And then root 18 is root 9 multiplied by root 2, which is 3 root 2. And then root 12 is just 2 root 3. Yeah, and then you'll just get that. Sketch this curve. It looks something like this because first of all, it's a cubic graph, so it'll look like this roughly. Okay, and it has a root at minus 2, so that'll be this one here, and then also when x equals 1. But this is actually a repeated root, so it only touches it and then it goes back up, so it doesn't actually go under the graph, under the x-axis at that point. So this is minus 2, this is 1, and then if you plug in x equals 0 just to get the y-intercept, you'll get minus 2 here. Hence solve where this is greater than or equal to 0. Well, it's clearly greater than or equal to 0 between this, and also it's actually just when you're greater than this actually. Yeah. Is that what I've put? Oh no, sorry, it says less than or equal to 0, yeah, so it'll be it's just when you're less than this. Show that cosine theta equals a half is one solution of this equation. Just replace where you see cosine theta here with a half, and then this is just 1 minus cosine squared theta, so plug 1 over 4 into this, and then just just do that. You'll get minus 1 equals minus 1. Find all the values of theta that solve this equation. We got this last time by putting this into 1 minus cosine squared theta and then just expanding and then collecting, and then just bring the 1 to that side there. And then this is just a quadratic. If you imagine instead of cosine theta it said x, so you'd have 6x squared minus 5x plus 1. You can do a little substitution if you prefer, but if you're comfortable just factorizing this, just go ahead and do it. So you get cosine theta equals 1 over 3, or it equals a half. Cosine theta equals a half, so you've got 60 degrees there, and then you'll have 300 degrees minus 60 degrees, which is 300 degrees. And then for this one here, you'll get 70.5, and then you'll do 360 minus that to get this. Hence found all the solutions of this equation. It's the same thing, but instead of thetas, it's 2 theta. So if we call all of our other solutions x instead of theta, okay, and then we want to find 2 theta. So this is just 2 theta equals all of these. Okay, and then we want theta obviously, so you just half all these to get that. And yeah, that's everything. That's fine. Except it's actually not, because so when it was just theta, the graph repeats every 360 degrees. But now that it's 2 theta, it repeats every 180 degrees. Hopefully that makes sense. So, you can do, instead of doing 360 take away these solutions, you do 180 take away them. Wait. Oh no, sorry, you do 180 add them because you want to go forward. Obviously, if you did minus 180 from each of these, you'd go into negatives, but that's not within the range. So yeah, just do that. So do 180 plus all of these because you're going into like the next period of the graph, if you imagine that. And then just keep on doing that until you get all the answers within that range. Given that y is in the set of real numbers, prove this. This is really long. Honestly, it just actually wants you to go ahead and just expand all of these. It's probably a smart way to do it. I couldn't be bothered. I put this into I think I put this into photomath to expand all this out. Just go really carefully. You know how to expand brackets, so I'm not going to go into detail, but you'll get this for this one, and then you'll get this for that one. If you just do this one first, you'll be able to kind of realize what this one will be, if you're just careful about where the negatives are. Collect these, you'll get that, and then I took away 32 from both sides because then they'll just cancel to get this. And you don't have to do anything fancy with these two numbers here, because you can just tell that, well, y squared is always greater than or equal to 0, and then y to the 4 will always be greater than or equal to 0 as well. I mean, it kind of makes sense. No matter what number you put in for y in the set of real numbers, you'll have a positive number, and the lowest that number can be is 0. So this will always be greater than or equal to 0. And you do actually need to say this for the last mark. Prove that the curve with this equation has only one stationary point, stating its coordinates. Okay, so if you differentiate, if it has a stationary point, that's when dy by dx equals 0. So set that equal to 0. And then what did I do? I divided by 10, and then I factorized out x squared to get this. First of all, here, don't bother factorizing this. It tells you it only has one stationary point. And we've already gone x squared equals 0 as a solution, so x equals 0 as a solution. So this here must have no solutions. So, just to check it, we'll just check its discriminant. So we've got b squared, so 2 squared subtract 4 multiplied by 1 multiplied by 3, which is 4 take away 12, which is minus 8. And because that's less than 0, because the discriminant is less than 0, it has this polynomial won't have any real solutions. So x equals 0 is the only solution to this. Therefore, it only has one turning point, which is that x equals 0. Plug that back into there to get what y equals. It's obviously minus 8. And that's your answer. A curve cuts the x-axis at this point here and has gradient function this. Find the equation of the curve. Just write this as 24x to the minus 3. You could just not do that and just integrate if you feel comfortable doing that. But if you write it like this, and then just obviously integrate this, so this becomes minus 6x to the minus 4 plus c. Yeah, obviously plus c, you never want to forget that. And then when x equals 2, y equals 0, we're saying, so plug that in, get c is 3/8, put that back into there, and that's 4 marks. Show that the perpendicular bisector of the line joining these two is the normal to the curve at 2, 0. So if it's a perpendicular bisector, well, bisector means to cut in half, so we want the midpoint between these 2 points. So the midpoint is just minus 6 plus minus 2, which is minus 8, and then divide by 2, so that's minus 4. And then you've got minus 4 plus 8, which is 4, and then 4 divided by 2 is just 2. So the midpoint is this here. And then the gradient, if you just check the gradient between these two, like the gradient of this line AB, it'll just be 3. You'll have minus 4 take away 8, which is minus 12, and then you'll have minus 6 take away minus 2, so that's going to be minus 6 plus 2, which is minus 4. So you have minus 12 over minus 4, which is just positive 3. And then you want the perpendicular gradient, so it's going to be a negative reciprocal of this, so it's minus 1/3, and it passes through this point here. So you've got y equals minus 1/3x plus c. You could use y minus y1 equals x minus x1. I couldn't be bothered. Just, plug in these values. If you've got a calculator, you can do it really quickly. You get c is 10/3. Plug that back into there. And then what is it? Is the normal to the curve at 2, 0. So the curve was this that we got. Okay, and we're saying, let's just write this bit more normally. We're saying that at the point 2, 0, it's the normal to this. So it must have this must have at that point 2, 0 a gradient 3, because these two must have gradients that multiply to get -1. Okay, if you find dy by dx of this, you don't actually need to, think about it because it told you in the last question. And then you put it at the point when x equals 2, you'll get gradient 3. And then you can obviously see that 3 and -3 are negative reciprocals of each other, so they're perpendicular, therefore it is a normal to the curve at that point. On the 18th of March 2019, there were 12 hours of daylight in Inverness, and on the 16th of June 2019, 90 days later, there'll be 18 hours. T is the number of days after the 18th of March 2019. State the value that Jude should use for A. Okay, so 0 days after that day, there was 12 hours of sunlight. So when T equals 0 and E equals 12, so just do that. This goes away to 0, so 12 equals A. State the value that Jude should use for B. We've got A is 12, so just plug that in, and then 90 days later. What was it? 90 days later, there's 18 hours. So when T is 90 and is 18, and then just take away 12 to get 6, and then because this just goes to 1. Using Jude's model, calculate the number of hours of daylight in Inverness on this day, which is 58 days after. So T equals 58. Put that into your calculator, you'll get 17.1. Using Jude's model, find how many days during 2019 will have at least 17.4 hours of daylight in Inverness. So we've got this with our values for A and B plugged in, and then when there's 17.4 hours, so n equals 17.4, rearrange, just get sine t on one side, you'll get sine t equals 0.9, and then inverse sine t to get 64.2, then 115.8 is your two solutions. These are days, so I just rounded them to get 64 and 116. And then the difference between them is how many days, because is how many days would have 17.4 or more, and that's 52. But you see, when you're taking away these two numbers, you're excluding this number and you're excluding this number if you think about it. So I added 1 and then I added another one, so I added 2 onto it to get 54. Now I checked the mark scheme for this and it said the answer was 53 days, but I can't understand why it is 53 days. It makes more sense to me that it'd be 54. But here it says answer which rounds to 50. So 54 or 53, both of them are fine. Explain why Jude's model will become inaccurate for 2020 and future years. Because she's using sine, but sine repeats every 360, not every 365. And because there's 365 days in a year, it's not going to be very accurate because you'll always be like slightly inaccurate every year. Explain why this is better. Well, first of all, she squished it in by 360 by multiplying it by 360, and then divided by 365 to like stretch out 365. So it repeats every 365, not 360. So it repeats every year, which is more accurate. This is the mechanics part. So a ball moves in a straight line, passes through two fixed points, which are 0.5 meters apart. It's moving constant acceleration. Speed of the ball is this. Find the speed of the ball. Time is not included here. The only CVAR equation which doesn't use time is this. Just plug in your values. Initial velocity at A is 1.9, and then the displacement is 0.5, obviously, between those 2 points, and the acceleration is A. So just plug that in, put it into your calculator, you'll get 2. So that's the answer. Particle P of mass 7 kilograms is attached to the end of a light and acceptable string. It hangs freely in equilibrium. First of all, it's not going to be this or this, right? Or even this. Yeah, it's not going to be any of these three. Obviously, the answer will be this, because if you think about it, how is the tension going to be 0 if there's like a force acting down? Yeah, the force might be cancelled out maybe, but it'd still be acting down. So like even if gravity acts in the other way, there's still a force there. It's not 0. So yeah, the T doesn't equal 0, but the resultant force can equal 0. And then these ones, obviously, I'm hoping nobody would have gone for these. A car starting from rest is driven along a horizontal track. The velocity of the car is this. It's modelled by this. Find the distance of the car. Find the distance the car travels during the first 10 seconds of its journey. And by the way, for questions like this, if you actually don't understand why I've said that, it's just because there's a lot of things in these papers which it is just pointless to constantly explain them every single time, because they might come up like often, or even if they're not often, then it's like kind of something you'd be expected to get right anyways. If I've kind of just glossed over something which you need a little bit more help on, please just ask me in the comments and I'll actually give you a proper answer to it. This is just for the sake of, so the video is not 40 minutes long. I find the distance the car travels during the first 10 seconds of its journey. This isn't SUVAT. You don't know that there's constant acceleration, so we're either going to need to be integrating or differentiating. If you think about differentiation, it's the rate of change of something, and the rate of change of velocity is acceleration. We don't want acceleration, we want displacement. So if you do the opposite, if you take the antiderivative, in other words the integral of velocity, you'll get the displacement, which is s. So integral of velocity with respect to time is s, and then so integrate all of this to get I've actually just written it in the most lazy way possible because I didn't have a calculator. Well, I mean I did, but I just couldn't be bothered to write it in. And put this into your calculator with t equals 10. You'll get 100 meters, which is a nice answer. Find the maximum speed of the car, give your answer to 3 significant figures. This is kind of like an optimization problem in disguise, kind of maybe. So if you differentiate this to get dv by dt, which was already on the other part, I think. No, it wasn't. Yeah, so if you differentiate to get dv by dt, this is just the acceleration, but I'm not going to write a here. Because if you think about this, this is an upside down quadratic, right? And you want the maximum speed, so there's going to be a stationary point there, okay? Because you'll be at the top there somewhere. That's where the maximum speed will be, and what like the x-axis will be the value of t, which gives you the maximum value for v. So yeah, bring this to the other side to get that. Divide by 0.072 and get rid of t as well. T definitely doesn't equal 0, even though that's a possible solution to this, because you can't. It's not going to be t equals 0 seconds. So t equals 40/3. Plug that back into there, because this is the value. This is the value which maximizes v. Okay, so plug that into there to get this, and you'll get 28.4 meters per second. Deduce the range of values of t for which the car is modelled as decelerating. So we got the first differential as this, okay, and this is acceleration, so we want this to be less than 0 because it's decelerating. If you solve this, you'll get t is 40/3 or t equals 0. We said that it's not going to be t equals 0 anyways, but if you imagine this, be careful, don't say it's between 40/3 and 0, because this says less than 0. Just look at this is an upside down quadratic, right? And if you want to be less than 0, then you want to be either less than 0 here, less than t equals 0 there, or you want to be greater than 40/3, right? Hopefully you can see that. Okay, so you want to be greater than 40/3 or less than 0. You can't be less than 0 because it's time, you can't have negative time. So t has to be greater than 40/3. But in the first part, it told you this piece of information. It told you it's between this and that. Okay, so you can't just be like infinitely big here. You're also bounded by this. So you're actually in between 15 inclusive, but also greater than 40/3. Two particles A and B lie at rest on a smooth horizontal plane. A has this position vector, B has this position vector. Calculate the distance. So it's just the difference between them, and then just use Pythagoras. So you'll get 13i take away 3i, which is 10i, minus 22j, take away 2j is minus 24j, and then Pythagoras to get this. I've just put a plus there because even if you do brackets minus 24 all squared, it'll still just be a positive anyways. So I've just done that. You get 26. 3 forces act on A. It remains at rest, so these must all cancel out. I've wrote this. This probably won't get you the mark, but I was kind of just going quick through this. But I'm hoping you can see that if you do 6i take away 2, you'll get 4. And then minus 10 plus 4 is minus 6. And it's the opposite of this, because 4 minus 4 minus 4 will be 0, and then you'll have minus 6 plus 6, which will be 0. So then it keeps it at rest. This force is applied to B, so it moves from rest in a straight line towards A. B has a mass of 0.8 kg. Show the acceleration. It's talking about mass and acceleration and forces, so you're using F equals ma. The force, the magnitude of the force, is just Pythagoras of this, and that's 13. It's a Pythagorean triple. So we're using F equals ma because force, mass, acceleration. Plug in 13, plug in m is 0.8 to get a, which is 16.25. Hence, find the time taken for b to reach a. We're going to be using this equation. Let me just explain one thing really quickly. So it's moved forwards from rest. It says from rest, 13 meters. So let's say to the right, 14 meters to the right. Okay, and then it's going to reach A. Now A was at rest, if you remember from last time. So it's gone forwards 13 meters, and now it's going back 13. So in total, it's traveled 26 meters. Its displacement is 0, but it's traveled 26 meters. Okay. So this, I know it says S here, but you should really imagine it as a distance for this, because the displacement would actually be 0. But anyways, yeah. So it would be 26 here, and then its initial velocity is 0 because it started from rest, and so this all goes away. Acceleration is 16.25, as we've said. Then just rearrange for t to get 1.8. Tractor and its driver have a combined mass of m kilograms. Tractor has 4m kilograms. There's a tow bar between them, driving force of this and a resistance force of this. A total resistance force of 600 newtons acts on the trailer, and they're both moving at 0.8 meters per second squared. It looks something like this. You've got this driving force here, and then you've got 160 newtons as a resistance force, and then you've got minus 600 newtons, which acts on the trailer. You've got tensions in the tow bar, equal and opposite. Okay, and what else? So this is m kilograms, this is 4m kilograms. Okay, we're going to use F equals ma because we're looking for mass, and we've got forces here. So if you resolve forces, it's better to do it on the full thing, because say if you just tried to do it on this tractor here, you'll get the resultant force is this take away that equals mass, which is just m, multiplied by 0.8. Now the problem with that is you'll have two unknowns, which is t and also m, so that doesn't really help. So if you instead did it on this full thing, so you did this take away that, take away this, and then plus that, because this is acting to the right, and then take away this, these two will just cancel because you're taking away t and then plus in a t. So those two cancel. This has a mass of m, this has a mass 4m, so 4m plus m is 5m, and then acceleration is 0.8 for both of them. So remember, just remember that F equals ma. This F is the resultant force, so it's the total force. So it's this, take away that, take away that, take away that, but also plus that, and these two will just cancel. You'll get m is 2580. Find the tension in the tow bar. M is 2580, so we'll just resolve forces just on one of these maybe. You could use this one, or you could use... no, don't use that one. Yeah, just use this one. So you do this, take away that, equals mass times acceleration, so this time is by 0.8. Just rearrange for t to get 8856. And at the instant speed of the tract, at the instant the speed... What? I just can't even read. At the instant, the speed of the tractor reaches 18 kilometers per hour. Okay, yeah, that's just written really weirdly. 18 kilometers per hour. We're using meters per second because it's SUVAT. I mean, you always use meters per second. This is 18,000 meters per 3,600 seconds. So it's this, which is just 5 meters per second. The tow bar snaps, and we want to find the time taken for the trailer to reduce down to this, which is 2.5 meters per second. So if you imagine this, and then this has just snapped, so the tension now is just 0. So if we do F equals ma on this, the resultant force acting on this is minus 600 n, because it's 600 in that direction there. And then we've got minus 600 ma, because it's force equals ma. This is 4m. M is 2580, so 2580 multiplied by 4 is 10320. Multiplied by a, so a is minus 5/86. That makes sense because it's decelerating, because it doesn't have this driving force helping it now. This is the SUVAT equation we're going to be using. Just look through them, and then just look through what we don't have and what we do have. Eventually you will come to find that we need this one. The final velocity of it is 2.5 that we want. The initial velocity is 5 as soon as it's snapped, and it's decelerating at 5/86, or accelerating at minus 5/86. Plug that in to get t is 43 seconds. And that's the full paper. Thank you for watching.